The idea of fine-tuning is that these constants and the initial conditions had to be very precisely set in order for a universe to do anything that would allow for the existence of life. Think of it as a sort of multi-dimensional control panel where all of these different factors in the universe, they had to be very precisely set.
It's been 30 years plus you've been tracking this. How have you seen the arguments adapted or changed over that time?
Honestly, it's been iron sharpening iron for the last 30 years, in which people on podcasts can critique these things. And we've got, especially at the kind of level of the local fine-tuning, we have a whole lot more data. I mean, I think there were 100 or so extrasolar planet discoveries when our book first came out. It's over 5,000 now.
Does the argument for fine-tuning still stand, or has it been defeated? Our guest today, Dr. Jay Richards, is one of the world's foremost defenders of fine-tuning and the thesis that we live in a privileged planet. Now, we're going to dive into this argument, consider some of the biggest objections against it, and then you're going to come back live on Tuesday at 4:30 Pacific Standard Time to take questions, take objections. So if you believe in fine-tuning or reject it, write in your question and comment, and we will take the best ones.
Yeah.
But before we dive in, thanks for joining me here at Talbot School of Theology at Biola to talk about this argument and the new movie coming out called The Story of Everything.
Sean, so great to be with you. I mean, we've talked and known each other for years, but I don't think I've ever been in the studio with you. So this is a lot of fun.
This is the first time, which makes it cool in person. So I appreciate you making the trip.
Sure.
I'm eager to dive in.
Yeah.
And I want to start by asking, as I said earlier, you've been one of the most outspoken and articulate defenders of fine-tuning. Take me back to when you first kind of encountered an argument for cosmic design, and how did it affect you, if at all?
So I had studied philosophy and theology, a sort of shameless mix of those things. So I knew about St. Thomas Aquinas' 5 ways. You know, one of those is a design argument, and was really interested, honestly, in arguments for God's existence. C.S. Lewis's apologetics in college were huge for me, really. It's not that I fell away from the faith. I just doubted it and needed some serious answers. Okay. And Lewis provided that, like he has for probably hundreds of millions of people. Yeah. And then I was doing a PhD in philosophy and theology at Princeton Seminary. A guy named William Dembski, who's known, you know, was actually working on, I don't know, like his 12th degree or something. He was working on a master's. And we got to be friends. And weirdly, the very first article I ever had published in an academic journal was about the fine-tuning argument. In fact, it was me, strangely, I mean, your audience will know the references, but I was taking Alvin Plantinga's ontological argument for the existence of God and necessity and these sorts of things, and applying it to the multiverse theory, the idea that, you can sort of explain away the fine-tuning by postulating, you know, lots of universes, maybe infinitely many universes, and thought I found, a sort of a problem that it ended up sort of leading to theism, whichever way you went. And so that's what kind of got me interested in fine-tuning. Well, Bill Dembski was in this part of this nascent intelligent design movement at the time. It was really before the program started at the Discovery Institute in 1996. And so really because of Bill, he invited me to Mere Creation. I'm just realizing right here in 1996 at Biola University, that's where I met David Berlinski. I think I met Steve. It's all the people, right? Mike Behe. It was about the time his book was coming out. And ended up, honestly, these kinds of encounters change your life. And so that's how I really ended up working on this really full time for some years. It was that kind of coincidence. I don't remember who told me about the fine-tuning argument.
That's
I think it was the anthropic cosmological principle by Barrow and Tipler. I think I had read that now that I'm thinking about it. But of course, Dembski and I being in the same place, I look back on that. I mean, it's still unbelievably providential. And of course, he was just sort of focusing on the sort of formal structure of a design inference. I was honestly always very interested in these cosmic arguments because you've got, you know, I think there's evidence for design in the origin of life and the structure of life and the origin of the universe, sort of across the created order. But I've always really been interested in these cosmic questions, honestly, just because I'm super interested in astronomy.
That's a great reason to do so. That's one of the best reasons. You have a personal fascination with it. Now, one more question before we dive into some of the evidence in the case. It sounds like you grew up in a Christian home, went through a period of doubt. So apologetics, intelligent design was presumably not a piece of the reason you were a believer, but maybe helped you hold on to your faith. Is that
That's
fair?
right. That's a really good way to say it. And so I would say, if anything, I had, like a lot of kind of Christian intellectuals. I think in college, I had come up with a way to sort of explain, okay, even if there's a kind of chemical evolutionary story for the origin of life, even if the Darwinian story is sort of true insofar as it goes, it doesn't explain lots of other things. And so I didn't initially really even sort of look at those questions. I was actually interested in things like the reliability of the New Testament evidence for the resurrection. Your dad, I'm old enough that your dad's evidence that demands a verdict. I was at a very liberal college studying the documentary hypothesis of the Old Testament. And so really sort of a reader of apologetics. But what it really did is it wasn't that I was an atheist and a materialist and needed to be convinced of that. It's just that you end up in an academic setting where you sort of take the truths of the faith for granted. I'm saying the Apostles' Creed every week. And then all of a sudden it's like, well, wait, maybe that's just because I happened to grow up with this, but is there any sort of good evidence for it? And somebody gave me that 6-pack of books by C.S. Lewis, and that played a crucial role. And then, you know, More Than a Carpenter. I'm sure you've been told this, but I mean, it's just now occurring to me. It was actually some of your dad's books that really shored up the questions about the reliability of Scripture.
Oh, that's super encouraging. And other people have told me that, but every single time it gives me goosebumps. So there's a lot of design arguments you could have leaned into, could have developed. And that conference here in 1996, I was a student in 96. I wasn't at that conference. I just wasn't there. I was probably playing basketball and doing whatever I was. It's amazing. I missed it. But like, why did you lean into the fine-tuning argument and the privileged planet? We'll unpack a little bit more what that is. But why did you say, this is my contribution? I want to develop and defend this argument.
Okay, so I would say it's probably several things. One is honestly providence and just sort of connecting with a guy named Guillermo Gonzalez, this astronomer. It turns out that Guillermo and I did not meet until about 1999 in person. But he was present at that Mere Creation conference as a postdoc, very quiet, introverted, so of course we didn't meet. And I was always interested in the fine-tuning argument, and especially the sort of cosmological argument, because it holds whatever your theory of the sort of origin and history of life is, right? It's like the whole show.
Like the age of the earth.
Yeah, it's like,
it's
like whatever you want to think about that. This one's really generalizable, I think, is why I was really attracted to it. And I thought the argument was great. I thought it could use some shoring up philosophically, and I've worked on that over the years. But really wanted to sort of say, okay, is there something new here? And then I read an op-ed by the time, I think he was a postdoc at University of Washington, a guy named Guillermo Gonzalez. This is the 90s when we just started detecting extrasolar planets. And so every extrasolar planet that would be discovered, there would be a news push, probably, controlled by the communications operation at NASA, about the possibility of extraterrestrial life. And it just made Guillermo grumpy because he said, look, it takes a lot more than just to sort of ball around a star to get a habitable planet. So he wrote this piece in the Wall Street Journal. I happened to read it. The University of Washington, that was literally 3 miles from where I was in downtown Seattle, working at the Discovery Institute. And so I just looked up his number and I called him. And he said, well, I've actually been wanting to call you guys at some point. I don't know if he would or not, And so he said, hey, I've got this cool article about eclipses. And so I went down to the University of Washington. We had lunch. I still remember this vividly. And it was an article called Wonderful Eclipses in Astronomy and Geophysics. And it was just about this interesting study that he had done. He thought, well, it's weird that from the surface of the Earth, we can see perfect solar eclipses. So this needs a little setup. So an eclipse, of course, would be, solar eclipse is where you're just basically looking at the sun. You're on a platform. Something passes in front of the sun, in our case, the moon, and it blocks out the light. People don't often think about it, but there's this weird coincidence that the moon and the sun have the same shape and size in our sky, even though they're totally different sizes and distances and all these things. And he just thought, well, that's kind of weird. Astronomers had noticed this, but they sort of treated it as weird. He thought,
is the sun 400 times the size, but 400 times the distance?
Exactly.
Am I remembering the ratio?
Exactly. Okay. And they're both really, quite spherical, at least to the naked eye. And so there's just this weird sort of alignment. And he thought at the time, of course, they'd developed software that made these kind of calculations easier. And he thought, I wonder what eclipses would be like from the other planets. And so he did this calculation. I think it was 65 of the major moons initially. So Mercury and Venus don't have moons. The Earth is the closest planet to the sun with a moon. And then you've got Mars, which has a couple of little kind of probably captured asteroid moons, not very spectacular. It's those really the giants when you get out to Jupiter and Saturn that you get a lot of moons, and then the outer planets. And the long and the short of it is he discovered, if you look at the 65 major moons, the one place where you really get perfect eclipses is the one place where there are observers, that is Earth.
Amazing.
There's this one kind of exception. It's Prometheus, a potato-shaped moon. And I think it's around Saturn, but it only lasts about a second and it hardly counts. And so that's just weird. And he was talking about, we were talking about this idea that, well, you know, we know about this fine-tuning argument that things have to be very precisely set up in the universe in order for life to even be able to exist, right? To even have a planet where a life can exist. But Guillermo, I mean, he was sort of speculating, but what if the universe is also fine-tuned for science itself, for discovery? Wouldn't you expect something like this? And what he was thinking was, he was thinking as an astronomer about how the existence of perfect eclipses had been very important in the history of scientific discovery. It's like a natural experiment set up, made it much easier to figure certain things out that we couldn't have otherwise. And so we thought, what if those things that are needed in a planetary environment, so the so-called local fine-tuning, right? The type of star you're around, the size of your planet, stuff like that, that's really important for life in a planetary environment. What if those things also set up the best conditions overall for doing science? That would be a new argument, right? It would be a new thing, a new set of data. And that was probably more than anything, I thought, okay, that would actually supplement all these other design arguments that are being developed. And it would actually, it works itself around, it circumvents certain objections that people make against the regular fine-tuning argument that maybe we'll talk about in a minute. But that was really it. I mean, and so in some ways, we were at the right place at the right time. I mean, other people could have figured out this argument. And when you do that, when you have what you think is an original idea, one day you're excited and one day you think, you're crazy. That's why nobody ever thought of it, right?
Totally,
and so you go back and forth, or you think, oh, this is sort of obvious because I've been thinking about it for 5 years. Well, we found that Kepler, Johannes Kepler, who was a crucial figure in the history of astronomy, had suggested this too, that it was important that the Earth rotate around the sun because it gives us this ability to calculate the parallax. It's this kind of mathematical calculation to be able to measure the distances to some nearby stars. And so his point was that God sort of set us up so that we could do science. So there were glimmers of this idea, but nobody had really sort of developed the argument in detail, in part because a lot of the evidence that we talk about in this book that came out, The Privileged Planet, was new. You know, we didn't have data about extrasolar planets until about the time we started writing.
I think I've told you this. We first met in 2004 at the Case for Creator conference.
I remember that.
And it was amazing. Hosted it when I was teaching high school full time. But The Privileged Planet is one of my favorite books. It was game-changing for me. It's one thing to argue that the laws of physics are fine-tuned to enable there to be life. But then our place in the universe, we have to have the right kind of sun, of the right distance, of the right age. We have to have surrounding planets. We have to have the right core. We have to have a moon and a certain tilt. Like all these things added up mathematically becomes impossible. But then you add the piece that says, wait a minute, these factors that enable us to survive also enable us to be in the best or an optimal position to make discoveries about the universe. That's where I was like, wait a minute here. This is like a tangible evidence for design. I think it's so compelling. Now, that's a whole conversation we could have about that, and I love that. But maybe tell me one more question before I'm going to ask you to explain fine-tuning to us.
Sure.
How have you seen the arguments in you said about so 1996, so it's been 30 years plus you've been tracking this. How have the arguments, maybe as a whole, but more particularly in astronomy, cosmology, and in physics, adapted or changed over that time?
So I would say like the philosophical precision of the argument has gotten better. In fact, a lot of people sort of, I'd say, on our side, like intelligent design friendly philosophers, pointed out there's some weaker and stronger ways to sort of formulate the argument like there is. And so I think that's gotten much better. I would say, if anything, the evidence has gotten much more solid. It's honestly, it's been iron sharpening iron for the last 30 years, in which people on podcasts can critique these things. And we've got, especially at the kind of level of the local fine tuning, we have a whole lot more data. I mean, I think there were 100 or so extrasolar planet discoveries when our book first came out. It's over 5,000 now.
5,000
yeah,
now.
So, it's a huge number. That's a lot of additional data. And we made risky predictions the 2004 edition. So they said, okay, look, well, we've got to prove that it's testable, right? And so I'd say that's changed. There was a period of time in which publicly making intelligent design arguments, especially in biology, was extremely risky. In fact, if you're not tenured, it's usually a bad idea to talk about it. But now, there are reasonable and respectable people that talk about these things. There are people that, it's almost don't want to mention names, but, tenured professors of cosmology that are sympathetic and make these arguments. I don't think that was really true 30 years ago. What happened is you'd get academics or philosophers who are maybe always a little safer to talk about these things. But I think it's much more in the general public. So that, one example. Charles Murray is a well-known conservative intellectual for decades.
Yep.
Okay. Oh, yeah. And so, he was a well-known kind of conservative libertarian atheist, basically. Just
total materialist.
Total materialist and atheist. Over the decades, he has this amazing story, of course, of just realizing there's a heck of a lot more to the existence of God and to the claims of Christianity. And in his new book, where he talks about taking religion seriously, he actually cites Steve Meyer's book, The Return of the God Hypothesis. In the book, he says, if you want to see some good arguments on this, here you go. Famous years ago, of course, Anthony Flew, a longtime atheist that became, I would say, a kind of a deist or a theist before he died, really because of these design arguments. And then people like Thomas Nagel, another atheist, I'd say we'd say at least a philosopher, or at least a naturalist, who both critical and skeptical of Darwinian materialism and also sort of realizes the force of this. And so I just think it's found its way into the culture much more deeply than it was before. It was just sort of highly risky. It was like this loyal opposition of crazy academics, that are missing the gene that causes them not to take risks. Now I'd say it's much more common to hear those kinds of things, though I do think the kind of citadels, the official spokesman for science, they still, I think, feel like they kind of have to maintain the materialist thing, but I just don't think the evidence is going in their favor.
And we'll get into some of that evidence. I just realized that my son is a sophomore here. He's 22 this month, and I have a picture holding him in my right arm and the privileged planet in my left hand, reading it before that conference. Just brought that back to me. But I want to make sure people know, we just had Dr. Meyer a couple Fridays ago. Yep. And then we did a live stream responding to objections to his case for cosmology. But it was myself and a philosopher, so we didn't lean into some of the scientific issues. We had Doug Axe the Friday after that. Came back and he addressed some of the tough scientific issues. You are going to come back Tuesday. So write in your philosophical objections, write in the toughest objections you have for fine-tuning or the privileged planet thesis. We will not ignore any that are stated coherently and relevant to fine-tuning. We'll take the best objections. So please list them in there. All right. We're like halfway in this interview, and I'm finally asking you to define what's meant by fine-tuning and maybe how you uniquely formulate the argument.
Absolutely. So fine-tuning is a pretty basic idea. It's just imagine that there are all these things at the cosmological level. So the cosmological fine-tuning factors, they involve things called initial conditions, which has to do with, what would the state of the universe at the very beginning need to have been like in order to be where we are now? Those are initial conditions. And you've got these constants, which are these numerical values like G or C, the speed of light, that take particular values within things that we call laws usually, which are usually formulated as differential equations. And the laws sort of just, take for granted the universe and say, here's how things will change over time, given the initial conditions and these constants. The idea of fine-tuning is that these constants and the initial conditions had to be very precisely set within very narrow requirements in order for a universe to do anything that would allow for the existence of life. So I'm not talking about, maybe there'd be fewer planets or something like that. Insofar as by life, we mean chemical life. So organisms that are made of chemicals that can transmit information, we can reproduce, we can build large three-dimensional molecules that code information, or proteins, things like that build our bodies. That's going to require certain things. And so if you have something that's off. Let's say the G is too low, and so the gravity is not sort of strong enough so that at the beginning of the universe just doesn't ever hold together, right? So it can't form planets or stars or elements. You're not going to get life in that universe. That's the idea of fine-tuning. Think of it as a sort of multi-dimensional control panel where all of these different factors in the universe, they had to be very precisely set. And if they were slightly different in various ways, it's not that you just get a kind of different universe with a different kind of life. You wouldn't get a universe that could host life at all. That's the idea of fine-tuning.
Okay, so before we get to an explanation about what best accounts for fine-tuning, is the way you describe this about, say, gravity needs to be fine-tuned 1 times 10 to the 40th power or so, is this largely and generally accepted within the scientific community? So the debate is over what explains it, not is it?
That's right.
Okay.
Now, you might have a technical debate about some particular case, but there are really, really well-established cases, maybe we'll talk about it in a minute, that, so far as I know, no one seriously disputes. The question is, okay, what's the best explanation for it? Now, if you were to look at the literature for a long time, it would often be called the fine-tuning problem, which is sort of funny.
Oh.
Yeah, so it wasn't like, okay, how do we sort of mess this thing up? It's a problem because it seems intuitively like if the universe is fine-tuned, maybe it needed a fine-tuner. It was fine-tuned, right? Yeah. And that's a problem for a certain perspective. But the basic idea of fine-tuning is overwhelmingly and broadly held, certainly by astronomers and physicists and cosmologists.
So I did a video with 100 apologists. And I think we interviewed you, now to think about it, ask them what they thought was the best argument for God. Creation was number 1.
Yep.
And that includes different arguments, but fine-tuning was one of the top. Second was the moral argument. I've wanted to do a video asking 100 atheists what argument, they obviously don't believe the argument works, but if you had to pick one argument, which one maybe gives you pause and suggests God to you the most? And I think it probably would be fine-tuning, just based on my experience in hearing some people talk. Yep. If atheists are watching and you have a different take, tell me. I want to know. I want to get it right. But people like Christopher Hitchens was like fine-tuning. So first off, it sounds like you agree with me. If so, what do you think it is about the fine-tuning argument that even people who don't believe maybe gives them a little bit of pause?
Yeah, and you're right about Hitchens. In fact, when I debated him in 2008, it was about God and science, and I camped out because he's very rhetorically gifted, so I'm not going to beat him there. Gifted. So I just sort of camped out on like these empirical arguments, and he actually conceded, well, maybe there's something to that. Maybe deism is true. I mean, it was like, right? So that's a concession. I think Richard Dawkins has admitted at different times that this is the one that maybe, is, if he were going to have to pick one, right? I think it's probably, first of all, who discovered it, right? So it's not like it was a bunch of Christians looking for evidence of, God's activity. It was just physicists or atheists, people like, Sir Fred Hoyle, that actually were able to anticipate and predict certain features of fine-tuning based upon his observations. And so there's that. It ends up being sort of at the bottom of what most people take to be, in some ways, yes, the most abstract and reductionist in a certain sense, right, as particle physics or cosmology, but also really mathematical. What people think in the kind of public imagination, the best kind of science would be something that's really robust mathematically, that you can build a model that can be tested. That's physics and astronomy, or physics and cosmology for sure. And so I think that's probably it more than anything else, is they realize, okay, we call these the hard sciences, people, and these are discoveries from hard science, and they were discovered in the 20th century. They were literally new discoveries. They weren't it wasn't just some kind of premise that people had always held. Nobody knew about the carbon resonance, right, in the 17th century, or the initial conditions. I mean, even the idea wouldn't have made sense. So I think that's probably it. Recent discoveries, generalizable, based on hard science, and discovered by people that clearly didn't have any kind of theological agenda, at least any pro-theological agenda.
That makes total sense. I'd never pieced some of that together. So again, if you're an atheist and you're watching or you're listening to this, weigh in, tell us. Do you find it compelling at all? Would you add anything to the list of what Dr. Richards said, take things away? But that makes sense. It's discovered by science. It wasn't Christians looking for it. In fact, tell us a little bit more about that. You said Fred Hoyle was one of the first.
Yeah.
What was some of the first discoveries? And how were people framing this when they first started to realize, wait a minute, what's going on here? And maybe why was it so surprising?
Yeah, so Hoyle, this is probably my favorite story on the fine tuning. And so in
Okay, good.
1953, so this idea of cosmic nucleosynthesis. So the basic idea is that you can get the elements that we learn in the periodic table as long as you assume a few things about the sort of initial conditions at the Big Bang, right? And then the formation of stars and things that happen inside stars. So, like our sun is using up hydrogen atoms and fusing them into helium atoms in its core, and it eventually runs out of helium and it works its way up the periodic table. But depending upon the size of the star, they can only do so much of this. And then the elements get heavier and heavier, and this kind of process of fusion doesn't work. And so then you need other things like neutron stars and supernovae and things like that in order to create these kind of physical conditions that can build the heavier elements in the periodic table. All right, so that's the idea of cosmic nucleosynthesis. And so if you look at the universe, it's actually mostly hydrogen and helium and then the other stuff, And so Hoyle was thinking about this, where they sort of had a fairly strong understanding of the math that would be required sort of in stars, the kind of astrophysics that would be required for this. But then he noticed essentially that, okay, in order to have a universe with a lot of life in it, you need carbon. Carbon has these very particular properties. There's just nothing else like it. And there seems to be a heck of a lot more carbon in the universe than there would be sort of in terms of common sense. And the reason is to get from helium, and then you get beryllium and lithium and boron to carbon. It's in the periodic table. So what happens is you need something to happen inside stars or these kind of stellar activities in order to fuse certain parts of atoms to get carbon. And so what you can get is you've got helium, all right? And so you can sometimes get 2 helium nuclei, right? So this middle part of these atoms. You can get 2 of them to kind of hang out together, but it's very, very unstable, and it will form something called beryllium-8, all right? Doesn't last very long. And so you need a series of jumps in order to get carbon, because to get carbon, you actually need 3 helium nuclei to hang out together for a long period of time, okay? And Hoyle said, okay, that's just not going to happen very often, and so you're not going to get very much carbon. There must be a resonance, and so the resonance is just this kind of particular property in which like imagine when you're swinging your child in a swing, right?
Okay.
And so if you figure out, okay, they're moving this fast, if you do it right and you push them at the right speed, they can go higher and higher. Whereas if you're off, right, you can mess it up. That's a resonance.
Okay.
And so imagine there's this thing, that sort of property of carbon in which there's a resonance in which things will happen more quickly. It's like a sweet spot. He predicted ahead of time. He said, given the amount of carbon that we have, there must be a carbon resonance at this particular spot. All right, so he predicted it just based upon what would have to be given the theory. Guess what? They did that. They checked it in the lab, and he was exactly right. So
That's
he discovered,
amazing.
and in fact, there's several of these resonances.
Wow.
It's the problem with the example is that it's so complicated. You kind of have to get chemistry and physics, but it's unbelievable, and astronomers and physicists know this story. And by the way, Fred Hoyle was an atheist who sort of he admitted it looked like this thing had been set up, but again, another person predicted this thing. It's like, okay, the common sense way of explaining this is that, wow, things had to be really fine-tuned, even at a level that we didn't really even understand in order to get to where we are. But of course, Hoyle it wasn't like he was sort of open to fine-tuning. He just said, well, there has to be a resonance like this or we wouldn't have really gotten so much carbon.
Didn't he say like a common sense interpretation is that somebody's been monkeying with
exactly.
physics? That
That's
was the
right.
way he...
Yes, a super intellect has monkeyed with physics. That's the common sense explanation. I think it just is. It's just the natural human explanation that we should feel comfortable in saying we're rational in believing that, unless you can give me a really darn good argument otherwise, because this is the kind of reasoning we use every day quite reliably.
Okay, so people are tracking and they're going, okay, 1953, an atheist is the one who comes up with this.
This one thing.
But I'm not sure I followed beryllium and the examples, et cetera.
Exactly. So
give us your favorite example when you're explaining it to somebody who doesn't have a scientific background.
It's not that one. You asked me the chronology, Sean. That's the problem.
Did. No, you answered correctly.
Yes, and then Sir Martin Rees and Brandon Carr in the 60s and 70s started noticing things like the particular masses of elementary particles and certain constants, right? And so people learn about the speed of light, for instance, and notice that actually those have to be really precisely fine-tuned. The so-called fundamental constants, the four forces of gravity and electromagnetism and what are called the strong nuclear forces that all seem to have this weird, the dial had to be set really precisely. But probably my two favorite, the first one is called the cosmological constant. And I'm thinking, okay, how to sort of simply explain this.
Yeah.
Think of the cosmological constant as like the properties of empty space. Like people often think, okay, if there was no atoms or planets, space is nothing. Well, space isn't actually nothing. It has these particular properties that can be described with field equations and all these kinds of things. And in Einstein's general theory allowed for the possibility of there being this thing called a cosmological constant, which is this like some value that's set to empty space itself. All right. And so scientists, I think, were hoping it would just be something simple like zero. And theory for a while actually predicted it was going to be way too large. We finally were able to sort of figure out what it was. And it is really crazy. And the reason that this is important is that think of the cosmological constant as like space having a slight repulsive force. All right. That's the simplest way, I think, to think of this. It's sometimes called dark energy. And so you have a big bang, you have the universe expanding, and the assumption would be, okay, you've got this initial expansion, and then that's going to slow down. So under the force of gravity, the universe itself, the expansion will slow down. Well, we discovered actually it's weirdly accelerating,
it's the opposite,
right? This kind of thing. And so what you realize is that at a certain size scale, if there's this very slight repulsive force, just to space itself, right? Then that might overtake the universe, like the attractive force of gravity at some point gets so weak that that very weak dark energy takes over and then creates this expansion. Well, it's a very, very precisely set. And so it's 1 in 10 to the 20th. So that would be, right? So this is a sort of or no, 1 in 10 to the 120th. Excuse me. 1 in 10 to the 120th.
Got it.
So it's 1 in 10 and then 120 zeros, all right? And so this isn't a number that you can comprehend, right? But it's very precise, right? That's how precisely the cosmological constant needed to be set. So in other words, it was just slightly different, right? You would get just an expansion that would just, the universe would just blow itself out immediately. You'd never form any elements, or it'd immediately recollapse.
Okay,
that's
so
one.
Okay, so this helps. Is this force is enabling the universe to expand at just the right narrow speed and rate.
Yes.
Varied by 1 times 10 with 120 zeros after it. It expands too quickly, or maybe crunches in itself.
Yeah, exactly.
And so you don't even have a universe in which there's stars and planets and life if it's not within that narrow range.
Exactly.
That's one example.
That's one.
How many as a whole are you solid saying there's 30, there's 50? Give us a solid conservative estimate.
Yes.
And if we add them together, how big would that number be?
I mean, this is the problem. People always ask these questions, and I don't know. And I wrote this thing, 10 or 12 years ago for Discovery Institute. It's like, here's the ones that we're sure of, and there was like 8 or 10. But there are these parameters. In fact, Luke Barnes and Grant Lewis and another philosopher, actually just last year, have a great journal article where they talk about this. And I think they talked about, there's conventionally something like 37 parameters. It kind of just depends on how you count these things.
That's fair. That's usually, I've heard about 3 dozen.
Yeah, exactly. And I don't, I'd rather have really solid examples. And in some ways, it's not like, I don't think there's anyone that says, okay, if you could just give me one more, then I would quit being an atheist, right? It's like, do you need more? I mean, I gave you that one, right? So it's 1 in 10 to the 120, right? It's like, if that's not going to do it, I don't know what to tell you. And then the initial entropy. This is from Roger Penrose. So this is one of a fine tuning of the initial conditions, and he calculated the initial entropy. In other words, basically how ordered would the initial conditions need to be precisely so that you could get a universe like ours. And he calculated in this case it's 1 in 10 to the 10th to the 123rd power. Again, to me, it's like, why do we need more examples here, people? Yeah, it's like, fair. Because what you're going to get is all the same arguments about multiverses or whatever for 1 example or 5 examples.
Which we'll come back to.
Yeah, and so in some ways, what I think the pattern is what's important is that the more we learn, if you'd been in sort of late 19th century and you thought, okay, well, cells are these little homogeneous kind of globs of jello, right? And life is sort of easy. You get some lightning and you stir things up and you're going to get these reproducing cells. And you kind of have these naive beliefs. And the general assumption also was that there wouldn't be this level of kind of precision required. Well, what was the trend of the 20th century was to just discover more and more examples of these until you get these mind-boggling numbers. It's like, okay, well, how many of these do we need before we rethink maybe that Victorian materialism that we are still sort of hanging on to from the 19th century, which is what I actually think is going on. That's the relevant thing. It's like, look at the pattern historically.
That's good.
Yeah, don't say, okay, I need just one more. If you give me 40 or 41, then that'll change my mind.
You mentioned the example by Penrose.
Yes.
Steve Meyer's coming back on early May, and we're doing kind of an in-depth response to Penrose's model. So that's something to look forward to, and we will really nerd out on that one. Okay, so here's a few counter arguments that I pulled from some recent books, and this is from an atheist by the name of Dan Barker.
Oh, yeah.
And he's co-written a book coming out with Erdman's this spring. I endorsed it, thoroughly enjoyed the book.
Yeah.
They talk about fine-tuning, and he has a few objections there, but one he says I've heard a lot is that the universe is not fine-tuned for us. Rather, we are fine-tuned to the universe.
Okay, so there's a bunch of things happening here. And so the idea is that, well, life adapts to the conditions that it's around. And so let's say you're very generous with the Darwinian mechanism and you think, given, kind of basic conditions, life can develop and adapt in all sorts of various ways. So let's just be super generous with that, all right? Fine. That doesn't tell us anything about the origin of life. So you don't have adaptation in the origin of life because you don't have things reproducing. And so the fact that life, under certain conditions, can adapt to certain things doesn't mean that every set of conditions is compatible with life. That's the whole point of the fine-tuning argument, is that when you're dealing with these fine-tuning arguments, certainly at the cosmological level, you're talking about what is needed for any kind of life, at least any kind of chemical life. And so before you can get an origin of life, before you can get natural selection and random variation and differential sort of populations and things like that, you got to get some basic things like being able to build elements, being able to build something like chemistry or like carbon, right, can build these molecules. And so he's sort of assuming that life has this infinite malleability so that almost any universe that exists, there'd be some kind of life in it. There's absolutely no reason to think that. And in fact, I don't think any kind of serious physicist thinks that. And so that's, I think, the fundamental difficulty with his argument. Even if you grant sort of the most generous assessment of the Darwinian mechanism, which I don't, I think it's very good at tweaking around the edges, but I don't think there's any evidence that it does major things. But even if you're a committed Darwinian, you've still got to deal with the basic reality that to have any kind of life, you're going to have some basic physics and chemistry. There's certain preconditions for it, and that's just not going to work.
That's a great answer, and I bring us back to the first cosmological example that you gave, cosmological constant.
Yes.
That's not fine-tuned with 1 times 10 to the 120th. There's not even a platform or the possibility of life developing, and that's one example. So, well said. I like that. Okay, I know you're familiar with this one as well. It's called the weak anthropic principle. Says we couldn't observe ourselves in a non-fine-tuned universe. So we shouldn't be surprised that we exist in a fine-tuned universe.
Okay, so as you said, it's called the weak anthropic principle. At least that's one interpretation of it. This one is the one that drives me crazy, Sean, because it's such a terrible argument that I can't believe smart people make it, honestly.
Wow.
Some of the arguments it's like you got to spend some time on, but it's just a confusion. It's confusing, a necessary condition for observing an event with the event itself, with like the explanation of the event. And so the sort of famous example, I feel like it maybe came from John Leslie or something, would be as if someone was, subjected to a firing squad and they were going to be executed. And, let's take 100 sharpshooters and they're just 5 feet away. They blindfold you, right? And you discover that the bullets make a perfect outline of the guy's body. They take the blindfold off and he could say, well, I shouldn't be surprised to see this because if they had killed me, I wouldn't be able to do that. It's just ridiculous. The question isn't why are you observing this? The question is why did they miss, right? And so the question isn't why do we observe a universe that is compatible with our existence? That's a truism. It's a tautology. Why does such a universe exist? That is, why, given how constrained and precise the fine-tuning had to be, why would it be that kind of universe that exists? Because the implication of the fine-tuning is that sort of the set of possible universes that can host life is, however you want to think about it or measure it, vastly smaller than the set where it doesn't work.
That's right.
And that's the thing that needs to be explained. And so it always surprises me that people will make this argument as if it's sort of satisfactory. It's like, look, yeah, the fact that you're observing it that's not the explanation for the existence of the thing. And that no one would ever make this mistake, I think, almost anywhere else, but they would make it here. It's like,
that's
it's like, yeah, it's like, oh, good, the bomb didn't go off that the mob was planting in my car, but I shouldn't be surprised that it didn't go off, because if it had gone off, I wouldn't be here. Well, if you notice that somebody cut the wires, that's the explanation, right? And so nobody makes this mistake. And so this is, if someone is having to, it's such special pleading that they're using an argumentative form that they would never accept in any other area, that's usually a sign that something's off.
Seems to me it confuses necessary and sufficient conditions.
Yes.
So to observe myself, I need to be in a fine-tuned universe.
Exactly.
But that doesn't sufficiently explain
Yeah.
where the universe came from,
Exactly.
why it's fine-tuned, and why I'm here.
Yeah.
I heard another example, and then we'll move on. I don't remember where I heard this one. But if I come home and my neighbor's in my closet, I'm like, what are you doing in my closet? It's like, well, everybody has to be somewhere.
We tell this story in The Privileged Planet. I don't know who told
that where it
but
came
I don't
from?
know who. I don't know where I heard it, but this is right. It's like,
That's where I got it. Okay.
the guy comes home early and there's a man naked, his neighbor's naked in the closet. And he's like, well, everybody got to be somewhere, right? Yeah. It's like, no, that's not
The question
work.
is, why are you here? And there's a pattern that requires explanation.
Exactly.
Okay, good. So let's move on. I have 4 for you. So 2 more. And by the way, folks watching, if you're like, wait a minute, there's a better objection to fine-tuning, write question in caps,
Absolutely.
Put it in, and we will address it Tuesday. So I've heard some people suggest that there might be a theory of everything we haven't discovered yet.
Yep.
Maybe some kind of natural law that would explain why we exist in a fine-tuned universe.
Okay, so first of all, there's sort of laws and there's explanations. And laws we've gotten in this habit of talking about laws as if they're sort of causal agents, right? But what G is it's a kind of mathematical value that we learn from observation about what bodies do in space, right? There's not this force called G that's moving stuff around. And so I think there's often a category error in this idea that, like, okay, if we come up with a theory of everything, I think the picture is that, we're going to have a theory and it's going to, let's say it has one constant. And from this one constant, you get all these other constants that we observe around us. And so they all sort of ultimately collapse into this one constant. It's not clear to me what that solves at all. It seems like it makes it worse. I mean, it would be like, okay, this guy is the best pool player you will ever see in your life. If he's allowed to break the balls, he will be able to sink one ball after another and you'll never get a turn. And then a guy shows up and says, okay, well, let me see what I can do. Can I break? And then he hits the balls and he sinks them all on the first shot, right? You wouldn't say, oh, okay, well, now there's nothing to explain. He would be the master, right? And so the fact that we would have some particular, it would have to be an equation. It would have to have constants in it. They would have to have particular values. They're not going to be logically necessary truths. And so we'd still have to explain, okay, why that very precise thing? In fact, that would be extraordinary that there would be a mathematical expression that could give rise to this. It wouldn't solve the problem of the fine tuning. It's just, it'd move the fine tuning up to a sort of different location.
Okay, that's the key that I hear Stephen Meyer talking about a ton, is that we come up with an explanation to explain away information which comes from a mind,
right?
But then we muzzle in information and don't explain what needs to be explained.
Yes.
So if there was some law that required or mandated or generated, it would still raise the question, why is the law the way it is that is resulting in fine-tuned universes?
Exactly. And now I perfectly accept if somebody says, well, you got to stop explanation somewhere. True. Everybody, like presumably every worldview, if it's going to be consistent, is going to have some kind of fundamental sort of mode of explanation, right? But there's no reason, it's not like, okay, so that's the one brute fact you're going to accept is this kind of thing that we've not discovered, this mathematical expression. It doesn't even sound like a causal agent. At least if you're a materialist that believes the universe is eternal, you can say, well, the universe is at least is eternal, right? So it's always existed. Now, we can't really say that now. But this one is very strange to me because it doesn't seem to do what you would even want an ultimate explanation to do. It does. It just ends up moving itself back. And that's why I think these design arguments, when you get to cosmology, ultimately beg theological questions, which require theological. Okay, so what's the self-existing reality, right? That's the question. And what's the best candidate for self-existence and, eternality or necessary existence?
Okay, so let's talk about the multiverse, which is the most common objection. And a couple weeks ago had Tim Pickavance, he's a philosopher, a colleague of mine here. We were responding to philosophical objections and questions about Meyer's scientific case from the origin of the universe. And multiverse came up. And I said, this is more relevant to fine-tuning, not the origin of the universe, because if you have a multiverse, you still have to explain where it came from in the first place.
Yeah.
But it is relevant, and it's a fair challenge to fine-tuning.
Sure.
So maybe just explain briefly so people understand there's not just one multiverse hypothesis. Just give us a sense of what that means and what your response would be.
Absolutely. And so Steve, in the Return of the God hypothesis, just lovingly chases all of these rabbits all the way down, It really, really does. In The Privileged Planet, we just dealt with them as we thought were relevant to our argument. But the basic idea of a multiverse is just that the physical universe that we see and can experience and can detect is one of perhaps countless other universes. And the reason this comes into fine-tuning is this idea that, okay, if there is only one universe, it would be very strange that there would the one that exists would be so precisely fine-tuned. If there's a lot of universes, then maybe somehow by chance one of them will just
if
sort
not
of end up
an infinite number.
Yeah. Now, if you get, of course, if you get infinite, right? If you can grant someone an infinite set of anything, you can prove a lot of stuff, right? Really, really easily. It creates other problems, and so that's the idea: is that you're just basically you say, okay, well, the opportunities for chance to operate are greater. It's just like if you saw me flip a quarter 30 times to get 30 heads in a row, you're like, okay, it's obviously two-headed or or something. But if somebody had been flipping it for years and they got 20 heads in a row, well, that would happen by chance. So that's kind of the basic idea. The problem is, depending upon the theory, as Steve points out, right, in his sort of discussion in the Return of the God hypothesis, either it doesn't answer the initial conditions problem, so it doesn't solve that problem, or it creates other kind of fine-tuning questions, and so then you move up and you need some kind of universe-creating machine that has to itself be fine-tuned, and it ends up not solving what you would think it's supposed to solve. If it's supposed to help explain away the fine-tuning, if it ends up creating additional worse fine-tuning problems, it hasn't actually done what it's supposed to do. And then in some cases, it might actually even imply theism, depending upon how you interpret certain theories. And so it doesn't actually solve what it's supposed to do. If you think, okay, the multiverse explains away this evidence of fine-tuning, that's the kind of popular conception, but people that I think that on all sides that really think about this realize, okay, it's not quite that simple. It's one of those things that seems plausible as long as you don't spend a lot of time thinking about it, but it just doesn't ultimately solve the problem. If you have to push the fine-tuning back, you've made the problem worse rather than better.
I did a full deep dive with Steve, I don't know, maybe 2 years ago, maybe it was less. And he talked about how, same as we discussed before, that if you push up to a multiverse, you don't get rid of fine-tuning. And to even generate universes like ours that are fine-tuned, you still have, he calls it like, what does he call it? The information cosmological problem, something to that effect.
Right.
I forget the title of it. And he pointed out, like, even in science fiction, I'm a big superhero guy, you have like these God-type figures between the universes regulating them, which is almost a punt towards there needs to be a kind of mind that we know, and of course the science shows. So if you have deeper questions about the multiverse, write it in. We'll come back on Tuesday. Last question. This one is kind of broad.
Yeah.
Are there any newer objections to fine-tuning that you're aware of or you've seen outside of the multiverse that have kind of popped up that either are strong or either getting a lot of attention that are worth responding to?
Well, I mean, there are ones that appeal to certain people but will not appeal to scientists. So scientists, for the most part, are realists. So they actually think atoms are real and planets. They really, not only do they think we went to the moon, they believe that there's a moon, right? That's how hardcore they are, right? And so they want arguments and evidence. And so for me, it's like, okay, well, we're arguing about the interpretation of evidence that's been uncovered by science and observation. I think that we're sort of in a loop of these sort of explanations. Now, if you're more into critical theory or something like that, and you have kind of a radical skepticism about scientific realism, and you do get those sorts of things. This idea that these scientific theories, they're so abstract, they're really just intellectual constructs developed by a particular culture at a particular time and place. That was actually kind of hot in the 90s, honestly. When Bill Dembski and I were in graduate school, I remember that postmodernism was sort of the thing. Everybody's reading the French postmodernists. That it digs in certain university departments, and it's usually if they end in the word studies, that's where you find this stuff. And so I've seen some arguments from folks like that, right? Or from a kind of radical empiricist theism in which our knowledge of God is so inadequate, that even being able to apply categories like design or purpose is anthropomorphic. I just find those super obscure, and I don't think that they're ultimately going to appeal, certainly not to scientifically trained people, but also I don't think to sort of ordinary people in the normal course of life. I mean, the design argument is powerful precisely because at bottom it just appeals to our basic modes of reasoning. We're really good at distinguishing, okay, that thing was clearly, that's a setup. That probably just happened because, the wind blew by. We don't always get it right, but we're very good at doing that. And so when you see these same kinds of properties in the physical universe, I think it's just natural to infer design, so that if you will not countenance the possibility of an intelligence that is outside the universe, that even created and sustains it in existence. Now, if you just refuse to consider that, that's one thing. But if you're open to it, I think the evidence is quite powerful. The evidence of the natural world points beyond itself to that kind of explanation.
That's the question I was going to follow up with and ask. What kind of worldview implications would follow from this? Yeah. And in our conversation about cosmology, if the universe had a beginning, and the science seems to strongly point that direction, you have a spaceless, timeless, unchanging, self-existent, personal agent that brought it into existence, rules out things like naturalism, arguably rules out things like pantheism, where there is no personal monotheistic God or distinction between creation and creator. That doesn't really rule out deism necessarily, the cosmological argument. So it narrows things down.
It does.
We talked about this a little bit with Doug, and he was talking about arguments from DNA and what we could potentially know about design. What does fine-tuning tell us about kind of what best explanation we have for the universe? How close could it get us to a God or the Christian God?
I think that as long as we can add a few plausible assumptions, right? And we can get a cosmological argument. I actually do think Bill Craig's arguments about the impossibility of an infinite regress work. But just the fact that we think the universe has an age, right? Whatever you think the age is, if you think it has an age, then that means it hasn't always existed. So that knocks it out. Like if the big question is something like some kind of theism or teleology, right, that's not dependent on matter, or a material universe, well, if all the evidence is the universe came into existence, it can't be the ultimate explanation, right? Unless you're just going to say, well, the ultimate explanation just sort of popped into existence uncaused out of nothing. I guess you could have that if you want it. That's not really what anybody means by an ultimate explanation. And so in some ways, as long as we could think the material universe was eternal, the materialists could just sort of say, well, I don't need an additional kind of explanation. I'll just stop with the brute fact of the universe. They can't do that now because we know the universe had a beginning. And that's in some ways why this whole conversation is happening. And so I would say insofar as theism at least says that you have a personal causal agent powerful enough to be able to bring a universe into existence and to sustain it into existence. No reason to take that for granted. That's something like theism. Now, we're not going to get the Trinity. We're not going to get, the two natures doctrine of Christ. We're not going to know God's personal name. Why would we expect that? I mean, I think as a Christian, God has created a world that testifies to his existence as a creator and that is sufficient at least to tell us that there's a moral law so that we're accountable, as Paul says in Romans 1. And that's knowable by reason. And we need special revelation. We need God to disclose himself as a person, and history and in the person of Jesus Christ, and Scripture teaches other things, but those are complementary things. And so I do think that if you sort of add up all the fine-tuning arguments, add a cosmological argument on top of that, in light of the contemporary evidence, circa 2026, I'd say you can get to a bare theism, certainly a deism, maybe a theism. And I think, especially if you take seriously the kind of ongoing reality of teleology in life, and I think honestly, I think God's deeply involved in the details all the way through. And if you can add that, then you're not just talking about a God like creating it at the beginning. You're talking about a God that's intimately involved throughout it. That's theism, and that's something, right? I mean, if the main intellectual impediment to Christian belief in particular is materialism, and you can get to theism, that's a totally different ballgame at that point.
Oh, for sure. And what's different about this is sometimes I've heard, and this is a weaker argument, don't hear it a lot, but that fine-tuning could be explained by something within the universe, like Prometheus, the alien movie, has a kind of fine-tuning, these aliens who seed a planet with life.
That's right.
That could work for proteins and DNA in principle. Whether or not it's the best explanation, separate issue, but in principle it could.
That's right.
Of course, fine-tuning is about the universe, so nothing within the universe could explain it. It has the same implications as the cosmological argument would, something beyond the universe that set it up.
And there is, I mean, honestly, because of things like Prometheus, there's this popular idea that, okay, well, maybe it's not a God, or maybe what we mean by God is just a really advanced alien race from a previous universe, right, that then is now creating universes. Now, at this point, it's like, okay, yeah, but you've conceded design, you've conceded intelligence, and then it feels really ad hoc, right? It's like it's this alien race of, because then you start getting into principle of parsimony and Occam's razor. A single God is a much more economical explanation. And in fact, I think if you really think about it, you have the fundamental sort of mode of explanation, that fundamental reality has to be something that's intrinsically a unity. It can't be made up of a bunch of sort of separable parts, or the parts would be fundamental. And this is, I think, the kernel of truth in this complicated idea of divine simplicity, which sometimes it can go too far, but just this idea that the fundamental reality is going to be something that unifies everything within itself. Well, an alien race that was in a previous, previous universe, that doesn't do that. That just sounds to me like, okay, I gotta have something, and it can't be God, so I'll go with this, even though we don't have any independent evidence of that.
I'd be curious what studying and developing this argument means for you personally. And if you're like, Sean, this is my ministry, this is my profession, I'm not fishing for something that's not necessarily there.
Right.
But you've been studying this for a long time. You've been doing debates, you've been writing journal articles, you said this argument is stronger than it was in the past, and I agree with you. Like on a personal level, whether your spiritual life or just the way, how does studying this affect you personally?
Gosh, that's a good question. I should say that, our book came out in 2004, and then Guillermo and I wrote a totally revised and rewritten edition with the new evidence, came out in 2024 because of the total eclipse. And so to revisit it, first of all, to discover that you weren't a great writer 20 years before, or at least that you've gotten better, right? There's that discovery.
Fair.
But also that's like, oh my word, we made a lot of risky predictions about type 2, type 2 supernovae and, 1A supernovae and lots of stuff that was risky that's panned out. And in fact, we've thought about some other examples that we added in the book that we hadn't thought of initially. That's powerful because it's like the natural world itself is sort of testifying to this. And I think, I don't know how everyone experiences it. I'll just speak for myself. But like sometimes you get yourself in a funk where it's like, I don't know, maybe I'm just making all this stuff up and it's totally crazy. And I can almost get myself, this is the problem with philosophy, right? You can almost get yourself in a state of doubt. But then I'll remember, oh, wait a second. But first of all the other alternatives are way worse. And what about this? And it reminds me of it. And I'm, of course, intimately acquainted with the arguments and the evidence. So it just sort of brings you back. That's why I think it's important to study this stuff because, God has to move you, obviously, and the work of the Holy Spirit in your life is crucial, but I think he wants to respect our reason, and we're rational animals. And so the fact that he's given us things that actually, they add up. They're confirmed by the best evidence of the natural world. That makes this, I think, a really exciting time to be alive. I really think there's never been a better time to be a theist than in 2026, honestly.
I love that. I'm going to clip that, throw that on social media. I think you're right. For me, some of these arguments, like I remember I went through kind of a doubting period when I was a student here. And I remember reading this skeptic who said, why doesn't God just write made by Yahweh on every cell? And then when I really studied DNA, I was like, oh my goodness, he kind of did. He kind of did.
Right.
And I can't look at a solar eclipse the same. A few years ago, there was one in Southern California, and I was able to watch it with the glasses on.
Yes.
And I'm thinking about, wait a minute, all the things that have to be lined up here are so mathematically improbable. And this enables us to understand the world, and it's beautiful on top of that.
Absolutely.
Some of this study for me has made me read passages like Psalms 19, 1 and 2.
Yeah.
The heavens declare the glory of God. The skies proclaim his majesty. Day by day they spew forth knowledge. Night by night they display wisdom.
Yeah.
It's actually objectively true.
Right. Yes.
All right, so I want to ask you about the movie in a minute.
Okay.
You're interviewing this.
Yeah.
It's fantastic. But before we get to that, do you have any sense about where debates about fine-tuning are maybe headed?
Yeah.
Like, what would be your guess if you had to say, here's where I think things are moving, and maybe in light of some trends you've seen change in the years leading up to today?
The fact that for a long time, I hate to say this, the reality is it was hard to have these debates because of the intellectual orthodoxy that made it costly. It was not costly in the academy to be a materialist. It was like, that's how you get tenure, right? It was costly no matter how careful you were. My co-author, Guillermo Gonzalez, he suffered in his career despite a stellar publication record, just simply because of being associated with this argument. I can remember I asked him one time, I said, do you think it was a good idea to write this book before you had tenure? And he's like, well, the idea, it happened when it happened. It's like we would have been suppressing this if we hadn't done it when we did. I haven't really suffered from it, and so I think that's changed. And so the things that worked in 2004 or 5 in terms of trying to sort of sideline the argument, I don't think there's going to keep working. And so if I were a materialist at this point, I would be trying to figure out a way to accommodate all the evidence, however I could, and then somehow sort of appeal to a type of agnosticism or something. Because the truth of the matter is, I don't think we're going to get fundamentally different kinds of arguments. You're going to get these multiverse arguments, you're going to get brute fact arguments, you're going to get attempts to debunk maybe the empirical details. It's very hard to imagine, there's only so many kinds of arguments that you can construct in this way. And so I'd be really surprised if there was some fundamentally new kind of argument. I think what you'll get is new strategies. As the kind of awareness of this stuff settles in, it would be much easier. Certainly for me, I'm thinking if I didn't want to cease being a materialist, I would want to do my best to kind of accommodate all the best evidence for this, and then just try to find some kind of exit ramp. And I'm not an atheist, so I can't quite anticipate how that would work.
That's totally fair.
I think that's what I would be trying to do.
Yeah, that's fair. That makes sense. I think one of the big objections to intelligent design is it's not testable, it's not falsifiable, doesn't make predictions. You guys made bold predictions in 2004, and it seems like most of them, if not all of them, came true as a whole, which even if they didn't, would tell us that ID in principle is testable and it is falsifiable.
If it's falsifiable, then
so it's kind of a win-win.
Absolutely.
But it turns out, I would guess you're going to predict that maybe we will find even more examples of fine-tuning.
More than happy.
Maybe in 10 years we sit down and there's 50,000 planets they found.
Yeah,
your thesis, you think we're going to find that Earth is even exquisitely privileged.
And we'll have a much better sense of what the ratio is, right? We're absolutely confident the ratio of habitable planets to uninhabitable planets is very significant. In other words, habitable planets, a very small number, and the uninhabitable is very, very high. We don't know exactly what it is. And so the more planets we discover around in different systems, around different types of stars, the more numbers we're going to be able to add to that. And so that's what I would expect, is that it will get empirically much tighter as we discover new things.
I love it. We'll have you back in 20 more years. Yeah. Actually, hopefully long before then. So tell us about the movie, The Story of Everything. Yeah. And I had a chance to see actually, I think it was finished, but on my laptop, they sent me a file. Fantastic. So well done. I've never seen a better movie on intelligent design. It deserves to be in the big screens. Yeah. But tell us what's unique about this film and why people should go see it.
Well, it combines these evidences. And so, when the nice thing about doing a film like this is, of course, people watch it. It's going to be a bunch of experts, sort of talking, but amazing animation, a narrative structure, so that you can actually see how these things connect. It's not like one little isolated piece of evidence about the origin of the universe, but there's a beginning of the universe. There's this fine tuning at the fundamental levels. There's there's the origin of life, there's the complexity of life, there's the competing explanations. And what's beautiful about it is, of course, a lot of us have always wanted to focus on, like in The Privileged Planet, if a person reads The Privileged Planet, we were criticized for this. We don't make a theological argument. We don't go any farther other than to say, look, we think this is solid evidence for purpose. We just didn't want to get out beyond the evidence. But as I just said a minute ago, I do think you line the evidence up a certain way and you can frame it in a certain way, you can get from the evidence of natural science to the existence of God. And that's what the film does. It finally it's the full picture. And in some ways, it's the full picture at the moment. Now, it's an hour and a half film, so we can't pack everything into it, obviously. But it's really great. It's also great because there are people of actually different Christian traditions, non-Christians, right, in the film. It's sort of all over the place talking about this, which is in some ways, I think it's a sign of the maturity of the research and the debate, that it's like, okay, look, lots of people are talking about this, guys, and so you can't say we can't have this conversation anymore.
It's amazing to think about the film Expelled that came out,
2008?
2008.
Yeah.
So almost 2 decades ago.
Yes.
And it was like the ID was on the defensive and there had to be humor and you need somebody like Ben Stein to even get a voice. This is like a mature, thoughtful, here's the case, we're part of the conversation, test it. Like we could almost do an analysis of those two films about how culture has changed and the debate about God has shifted. And of course, that was in the height of the new atheists when everybody was like attacking and going at.
That's the key thing. That was the peak of new atheism. That was when I debated Christopher Hitchens.
It was
at
the same
Stanford.
year.
It was part of the kind of run up to the film. That's why Ben Stein was the moderator. And new atheism was just everywhere. Well, I won't mention them. I've got 2 friends that I'm very close with that work on other issues. These guys were really active in new atheism. That is deader than dead at this point, right? It's like, that's just not where the action is. There's other stuff happening, but that was the impression, all these, all this adulation about this kind of movement, and it just petered out. And so I think that's a sign of how things have changed since the sort of beginning, because ID sort of emerged alongside the new atheist movement. It's petered out.
It did, yeah.
Yeah. We're still here.
Yes, you are. Although you predated it in the 80s, if you go back in the 90s. We're here arguably stronger than we've ever been.
Yeah, totally.
Dembski and I, Casey Luskin, are updating the book on ID that we released, as I think about it, was also 2008, Understanding Intelligent Design. So good things are happening, but it feels like a certain maturity that's come where we're just doing the work and moving forward. For those who want to engage.
Definitely.
Folks, if you're watching this going or listening going, okay, wait a minute, you did not consider this objection, write it in. Write the word question in caps as succinctly as you can. In fact, if you don't have any objections, you can write in ChatGPT, give me the best objections to fine-tuning. And if you care about that, load them in here. We will not ignore any that are on topic and are the best objections. Write it in so you can invite your Christian friends, your skeptical friends, whoever to participate. Jay and I will be back Tuesday at 4:30 to take your questions. Check out the film, The Story of Everything. It's so well done. Go support it in theaters. When it's done, download it, watch it.
Infinite universe would relieve us of the necessity of understanding the origin of matter at any finite time in the past. Notice that verb, relieve. That's not a scientific term. What does Dickie mean? Well, if the universe is eternal and infinite, then we don't even have to ask the question where it came from. So if an infinite universe relieves us of the necessity, what does a finite universe do? And so whatever explains the finite physical universe must be itself non-physical. Whatever explains the finite material universe must itself be immaterial. We get in this way to the philosophical stopping point of the first cause.
Before we go, anything else you're working on that's coming up that you want to tell us about, or how can people follow you?
Follow me at X I'm a Gen Xer, and so X is the main social media, but at Dr. J. Richards, Dr. Dr. And then my name, J. Richards. And I'm actually working on questions about health and chronic disease, actually at the Heritage Foundation, working on this weird reality that American children are developing these crazy chronic diseases, which actually has a tie-in to these questions. And so this stuff, this isn't just sort of metaphysical and interesting. I mean, I think these ideas actually have a role to play in public policy and in our health, actually.
I love it. Well, let's have a follow-up conversation about that. Jay, we'll see you Tuesday.
Thanks, Sean.